Welcome back, everyone. So if you've completed part two of this activity with your class, the big question is now, well, what are the chances that the students can do the work on their own? And we're going to put that to the test right now. Part three asks you to create some smaller, or at least smaller groups and provide different opportunities. If you're teaching in Zoom, this would be a great chance to, of course, use breakout rooms. If you're teaching in a classroom physically, then obviously you could just break the students up into smaller groups around the classroom. Groups of 4 seem to work out really well in my class, but depending on your experience or how the class is set up, sometimes the classroom dictates the number in each group. Just kind of break them down, have a few students start with each example, and then each group can have a reporter share the solution. When you come back as a full class, you can kind of tell people how the table was created and how they solved the problems. I recommend checking in with the groups a couple times during this time period. So this might take somewhere around 10, maybe 15 minutes, depending on your students, especially at the beginning. So remember, the first few steps of creating that table really are the basis for everything else. So check in a little bit at the beginning and make sure that they're on the right track. In case you're wondering, yes, there's different examples or different contexts. You could even have your class, if you wanted to practice again, create a new table or do a different example. The examples we chose: contract cheating with college students, racial differences in medical treatments, and then personalities and careers. Is there a connection? Basically, regardless of the example they choose, they're going to get similar questions asked. Here's kind of the typical questions. Fill out the tables like you're used to. In this case, I prompt with using 10,000 as the grand total. Suppose we select someone at random, and then a kind of a general question that starts out, followed by the conditional probability that is reversed from what was given in part of the problem. As you can see from this part 3, why is the answer to the previous question not 0.364, which was the probability going the other direction? So again, we're kind of switching these around, throwing a little bit of Bayes' theorem at them without even using that language. We don't need to complicate this, but hoping that they can use the table to say, well, the condition is different, the group size is going to be different, and let them explain that option. And lastly, we want to make sure that they're interpreting probabilities and they can put the language back into the context of the problem. So don't let them get away with just saying, what is the probability? And it's a 0.15. 0.15, what does that mean in the context of this problem? And I found that the more you can add those interpretations in wherever you possibly can, the easier it is later when they have to interpret a p-value that is a conditional probability when we're doing something like a hypothesis test. So take the time now to make sure their language is good with conditional probabilities and their explanations, and later you'll be able to connect that quickly to something that you're doing down the road. I'd recommend, if you haven't done them, that you try all the examples on your own so you can see possible pitfalls for your students, as well as things you want to focus on in the subsequent units. And that should wrap up part 3 of this module. All right, off you go.